Okay, please find the coordinates of the minimum. Okay, so I know it says the coordinates, so that's the x and y. So, okay, so we're gonna have to find the second derivative, which is right here, and set it equal to 0. So factor out it for x squared. So we get x equals to 0 and x equals to -3. So I am going to use the line. I'm going to check -3 and 0. So I need a number to the left of -3, so -4. So notice that my first one is always going to be positive. So I just need to check the x plus 3. So -4 plus 3 is negative. So cross it off when you're done. And a number between -3 and 0, so -1. -1 plus 3 is going to be positive. The number to the right of 0, 1. So again, that's going to be positive. So my minimum occurs when x equals to 3. So the coordinates would be, I have to substitute. So x equals to 3 is the minimum. To find my y value, I have to substitute -3 into my equation. Okay, to find the points of inflection, I need to find the second derivative, which would be 12x squared plus 24x, and set it equal to 0. So I'm going to factor out a 12x. That will give me x is equal to 0 and x is equal to -2. So once again, to find the points of inflection, I'm going to do a number line. And I'm going to check -2 and 0. So number to the left of -2 is -3. So this is going to give me a negative number times a negative number. So that's going to be positive. So from -2 and 0, I'm checking -1. So again, 12 times -1 is a negative number. -1 plus 2 is a positive. So that gives me a negative. To the right of 0, I'm checking +1. So 12 plus 1 will give me a positive. 1 plus 2 will give me a positive. So positive times a positive. So both x equals to -2 and x equals to 0 is where my points of inflection occurs. So again, to find the y value, you need to substitute these points into your original equations to find the y value. Show that the function f of x squared satisfies the hypothesis of the mean value theorem on the interval, then find the solution. Okay, to satisfy the hypothesis means that it has to be differentiable and continuous, and it is, and it has to be a closed interval, which it does. Okay, so now we're going to find a c such that the instantaneous derivative is going to equal to my average derivative. So the first thing I'm going to do is I'm going to find the average derivative. So I'm going to have f of 2 minus f of 0 all over 2 minus 0. So that's going to be 2 squared minus 0 squared over 2, 4 over 2, which is 2. Now I'm going to find the derivative. And then finally, I'm going to set my derivative equal to my average derivative and solve for x. So at x equals to 1, the instantaneous derivative is going to equal to the average derivative. Okay, so for 13, find the limit as h goes to 0 at the point x equals to 2. Okay, so if you guys see this, this is the definition of the derivative. So the limit as h goes to 0 of f of x plus h minus f of x all over h. So by looking at this, f of x is x to the fifth. So the derivative, which is the definition, is equal to 5x to the fourth. So 5 at 2 to the fourth would be 5 times 16, which would be 80. What is the slope of the line tangent to the graph at the point? So again, you're going to have to use implicit differentiation. So we're going to have 6x minus 3y squared times y prime is equal to 0. So negative 3y squared y prime is equal to negative 6x. So y prime is going to be 6x over 3y squared, or 2x over y squared. So as we substitute my x and y value, I'm going to have 2 over 4 or 1/2. Okay, so 15 says the graph of the function is shown below. So this is my original graph. Which of the following could be the graph of the derivative? Okay, so looking at the original, we're going to have 3 points where the derivative is equal to 0. So that means I'm going to have 3 zeros. Okay, so this one only has 2, so it can't be that one. This one only has 2. 1, 2, 3. So this is a possibility. That one only has 2. 1, 2, 3. So that one's a possibility. Okay, so the answer is either going to be C or E. Okay, so to the left of this 0, my function is decreasing. So that means that my derivative is going to be below the x-axis. Okay, so at this point, it needs to be below the x-axis, which is right here. Okay, from this point to that point, it's increasing, so it's going to be above the x-axis. And then from these two, it's decreasing, so it's going to be below the x-axis and then above. So the answer has to be E. The graph of the function is shown below. At how many points would the graph of f prime, the derivative of the graph, intersect the x-axis? Okay, so once again, this is my original graph. So it's asking at how many points for f prime, the derivative, intersect the x-axis. So it's asking how many points is the derivative going to equal to 0. So it's looking for max and min. So that's going to happen here. So at 1, 2, 3, 4, 5. So at 5 points. Okay, so 17 says the graph of f of x, x cubed minus 12x minus 6. So it's asking which one of these is true. So since we're looking for increasing, we're going to find the first derivative. Set it equal to 0. Okay, so x is going to be plus or minus 2. So let's do a number line. So we're going to check negative 2 and 2. So to the right of negative 2, we're going to check negative 3. And we need to check our derivative. So at negative 3, that's going to give me 9. 9 times 3 is 27. So that's going to be positive. I'm going to check 0. So again, 0 minus 12, so that's going to be negative. And to the right, 3, so that again, that's going to be positive. Okay. So it says it's decreasing for all real values. That's not true because I have some places that it's decreasing. It's decreasing for all x such that from -2 to 2 only. That's true. It's increasing such that x is greater than -2. No, it has to be less than. It's increasing for x is less than -2 only. It is increasing for x is less than -2, but it's also increasing for x is greater than 2. So that can be it, and it's increasing for now. So the only answer is B. Okay, the graph of the derivative of the function is shown below. So this is the graph of the derivative. Which of the following are true about the function g? Function g is increasing for x is greater than 2. So x is greater than 2. Okay, so this is the derivative. Do you see how this is above the x-axis? So that means the derivative g prime is greater than 0. So that means that since the derivative is positive, it is increasing. So that's true. The rest of the function is below the x-axis, so that's going to be negative. So that means that my original graph is decreasing. The function g has 4 points of non-differentiability. No, that is not true. The second derivative has 4 points of non-differentiability. 1, 2, 3, 4. But because I'm looking at the derivative and I have a point that is not an open circle, the the derivative of g exists from -4 to 4. Function g is not continuous function. Okay, that's not true. Since I'm looking at the derivatives, if it has a derivative, it's automatically continuous. So the only answer is C. The graph of the derivative of the function is shown below. So again, we're looking at the derivative of the graph. Where on the intervals from -2 to 3 is the function increasing? So the function is increasing when my derivative is positive. So it has to be above the x-axis. So it's only above the x-axis between -2 and 0. So this is the part where it's increasing because it's above the x-axis. Okay, if the limit is equal to this, it's equal to 2.637, and the graph of the function f at -2 is, okay. This is the definition of the derivative. What this just means is the derivative of -2 is equal to 2.637. So the derivative of -2 is positive. Okay, so it's a positive number. So since it's positive, my function is decreasing. No, if the derivative is positive, it is increasing. Okay, so it has to be both. B. I don't know whether it's concave down because I need to find the second derivative. If the second derivative is negative, it's concave down. Stationary means it's not moving. That's not true. And again, it's concave upwards if the second derivative is positive.